Similarity transformations. Draw a dilation of quadrilateral ABCD with the vertices A, 2, 1, B, 4, 1, C, 4, negative 1, and D, 1, negative 1. Use a scale factor of 2. So in this example, we have, these are our initial points. These are our pre-image points. Our image points are the coordinates after a dilation with a scale factor of 2. So we take our x and y coordinates and we multiply both of them by 2. So if we have A at 2, 1, 2 times 2 is 4, and 1 times 2 is 2. So our image of A is 4, 2. For B, 4 times 2 is 8, 1 times 2 is 2. So our image of B is point M at 8, 2, and so on. These are all just multiplying our coordinates by 2, and we get our image points. Anytime that you're dilating about the origin, you multiply your x and y coordinates by the scale factor. So let's look at what this actually means. So here's our origin. From our origin to the A is that distance. Well, now to L, the image of A, is twice the distance, making A essentially the midpoint between the origin and its image. It is now twice the distance. And this is exactly what's happening with all of these points. So from the origin to M, you can see that the B is the midpoint because it's halfway to the M, because we have a scale factor of 2. It is now twice the distance from the origin that it was originally. A triangle has the vertices A, 4, negative 4, B, 8, 2, and C, 8, negative 4. The image of triangle ABC after a dilation with a scale factor of 1/2 is triangle DEF. Sketch triangle ABC and triangle DEF. So our original triangle has these vertices, A at 4, negative 4, B at 8, 2, and C at 8, negative 4. Our image points are going to be triangle DEF. So our image of A is coordinate D, point D. We have a scale factor of 1/2. Multiply by your scale factor. 4 times 1/2, or half of 4 is 2. Half of negative 4 is negative 2. 8 times 1/2 is 4. 2 times 1/2, or 2 divided by 2, is 1. 8 divided by 2 is 4. Negative 4 divided by 2 is negative 2. And these are our image points. So we're going to plot our originals and our images. Always get into the elevator before you can go up or down. Remember, you must always get into the elevator before you can go up or down. So you go over to 2, down to negative 2, plot your point, and so on. So once again, when we look at these, if we're comparing from the origin to A, we have this distance here. Half of that distance is our image point because it's half as far. The scale factor is 1/2. If you're looking at your side lengths, if you're looking at your side lengths, so originally 1, 2, 3, 4, 5, 6. This had a height of 6. Now it's 6 divided by 2 is 3. Now that this length is only 3 because the scale factor is 1/2, and half of 6 is 3. It also wants you to verify that the two triangles are similar. So once again, okay, so that they are similar. So this is 6 versus 3. This is 1, 2, 3, 4. 4 times 1/2 is 2. This is 2. So we're good there. These are definitely proportional. You can see in the drawings. And these are both 90-degree angles. So by side angle, similarity, we know that these two triangles are similar because they have two sets of proportional sides and the included angle is congruent. So by side angle, side proportionality, we know that these are similar. Okay, so your side angle, side similarity theorem. We have two sides that are proportional and a congruent angle that's sandwiched between those two sides. Whenever we list our similarity statements, make sure they are listed in the corresponding positions. So angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F. Side AB is proportional to side DE as BC is to EF, as AC is to DF, right? We have to make sure we list them in corresponding positions. Find the coordinates of LM and N so that triangle LMN is a dilation of triangle PQR with a scale factor of K. Sketch the two triangles. All right, so we have our PQR and our scale factor is 4. So now we need to find what are the coordinates of L, what are the coordinates of M, and what are the coordinates of N. So for our L, we are multiplying by 4. Negative 2 times 4 is what? Good, negative 8. Negative 1 times 4? Negative 1 times 4, guys? Negative 4. Negative 1 times 4? 0 times 4? 0 times 4? Negative 1 times 4? And those are our image points. And when we graph them, we can see that this is clearly an enlargement. If we're looking at our original Q was negative 1, 0. It was a distance of 1 from the origin. 1 times 4 is a distance of 4 from the origin. So now we're at negative 1, negative 2, negative 3, negative 4, 0, right? So negative 1, 0 times 4 is negative 4, 0. It was a distance of 1, now it's a distance of 4 from the origin. And on our next one, we once again are looking for the coordinates of L, M, and N. And on this one, we have a scale factor of 0.4. What is 5 times 0.4? 2. Good job. And negative 5 times 0.4? Negative 2. 10 times 0.4? 4. Negative 5 times 0.4? Negative 2. 10 times 0.4? 4. That looks like a 9, sorry. And 5 times 0.4, 2. Now that we have our image points, we can plot them. 0.4 is less than 1, right? Greater than 0, less than 1. This is a reduction. This is greater than 1. It's an enlargement. It got larger. This one is smaller, so our image is here. A lot of times, instead of using different letters, they'll use, for the image points, an apostrophe. So instead of L, they could use P prime for the image of P. Q prime. Primes look like this. It's just an apostrophe saying I'm the image. You are making your own photo stickers. Your photo is 4 inches by 4 inches. The image on the sticker is 1.1 inches by 1.1 inches. What is the scale factor of the reduction? Oops. So, here's our original. Here's our new one. So originally we had 4 inches by 4 inches. Now we have 1.1 by 1.1. Once again, inches. So they're both squares. So 4 is to 1.1. Would it be 4 is to 1.1 for our scale factor, or 1.1 is to 4? Which one would make my image smaller? A reduction. Which one, guys? 1.1, because we want it to be a number that is less than 1, greater than 0, less than 1. Can I have a decimal in my answer? In a fraction? No. Move my decimal over once. When I do the top, I must do to the bottom. So we're going to actually end up with 11 over 40 for our scale factor. Make sense? And always pay attention to your units. They gave us inches in both of these, so that's why we didn't have to do any conversions first. You want to create a quadrilateral EFGH that is similar to quadrilateral PQRS. What are the coordinates of H? So, H goes with S. P and E go together. R goes with G. And F goes with Q. All right, because they're listed in corresponding positions. So, going from R to G, we had 2 from the origin. Now we have 1, 2, 3, 4, 5, 6, right? It went from 2 to 6 from the origin. 2 times what is 6? 2 times 3 is 6. So let's look at these coordinates. The coordinate is 0, 2. If I multiply 0, 2 by a scale factor of 3, I would have 0, 6, which is the coordinates here. So we know that, yes, our scale factor is 3. So if I take this original point of 1, 2, 3, 4, get into the elevator before you go up or down. 4, comma, 1, 2, 3, 4, 5. So I take the coordinates 4, 5, and I apply a scale factor of 3. 4 times 3 is 12, and 5 times 3 is 15. So my missing coordinate should be at 12, comma, 15. Make sense? Suppose a figure containing the origin is dilated. Explain why the corresponding point in the image of the figure is also the origin. So, suppose a figure containing the origin is dilated. It's made larger, it's a reduction or an enlargement. Explain why the corresponding point in the image of the figure is also the origin. What is our center of dilation unless stated otherwise? The origin. And the center always stays the same, right? Well, think about it in this one. If your scale factor is 3, 0, 0 times 3, 0 times 3 is 0, 0 times 3 is 0, it's still 0, 0. 0 times 1/2, 0. 0 times anything is 0. So your origin will always remain your origin. When you multiply it by anything, it'll still stay 0, 0. So that point will be a shared common point. And that was our entire lesson.